Hi everyone, welcome to the channel. Today I would like to go over some questions about parametric curves, mainly about domain and range. And the questions that I'm going to discuss can be found from the Core Maths 2 and this exercise 8A, question 6 and 8. So before I get into those questions, I just want to quickly have a review about how you can find domain and range using the parametric form. But feel free to skip this part of the video if you're happy with it and you just want to take a look at these two questions. Right, so let's get started. So if I have a Cartesian equation, like say for example y equals x squared over 4, that's the Cartesian form because it's written just in x and y. And if I want to find the domain and range, you can remember this cross. So the domain being all the possible values of x, and the range as the possible values of y. And let's say if I have no idea how to draw this curve, and hence I can't find the domain and range, and we can rely on the parametric version of it. So they are both now, you can see, written with a third letter t, x equals 2t and y equals t squared. If I would like to find the domain of my Cartesian form, I can still use these two, draw the graphs of these two, and just look at the range for both of them. Okay. So let's say if I look at the function of x in terms of t, x equals 2t, you can see that I draw a straight line here. So the range of x equals 2t, x against t, that will represent the domain of y equals x squared over 4, and hence in this case the domain of y equals x squared over 4 is all real numbers, and we'll write x is a member of all real numbers like that. Whereas for the range, we'll draw y equals t squared on the y against t axis, and y equals t squared at this, and at that perspective is just a parabola, and hence we can see that if I just look at the range of this function y against t, then it just defined from 0, which is the minimum point, all the way up. And in other words, we can say that the range of the function y equals x squared over 4 is y bigger than or equal to 0. Okay, so we can use these two curves to help us to find the domain and the range of the Cartesian form. So having said that, we will use it to solve these two questions in hand. So first one, question 6, it wants to find the range of x and y in the given domain t, which is t is a real number and it cannot equal to 0. Okay, so if I want to find the range of x, then I need to draw this graph x against t and find the range. So let's pay attention to this this curve closely. So 3 over t, it is a reciprocal graph, and since this number is positive, we know that this graph 3 over t will have a shape that looks like this, with a horizontal asymptote of y equals to 0. And if I add 2 to it, then we have, we'll just move this up by 2. So hence, if I draw this x against t, 3 over t plus 2, we're just going to shift the original horizontal asymptote up by 2, and we can just draw it with the same shape. Okay, so notice now, because our vertical axis is in terms of x, so we call this now x equals to 2. Before, this is y against x, so this line is y equals to 0. And you can see that this curve is everywhere defined apart from this horizontal asymptote x equals to 2. So we can say that the domain, which is the range of values of x, will be using set notation x colon x not equal to 2. So anything apart from that will be alright. So if you want to use the same way that I write there, you can say actually instead of x is not equal to 2, you can say something like x is all real numbers. That's what that means. And also x cannot equal to 2. Alright, and then now let's look at the second one. If I want to find the range of values of y, what should I do? So y equals 2t minus 3 minus t squared is a quadratic equation. So let's take a look at it. So firstly, I'll try to find the roots. And since that is not really easy to factorize, we can just work out b squared minus 4ac first and see if actually we have any roots. So we have 2 bracket squared minus 4, bracket minus 1, bracket minus 3, and now 4 minus 12, which give me minus 8 less than 0. It means, in other words, that it is it's not going to touch the horizontal axis in this case when I draw y against t. So it's not going to touch the t-axis, and since we know that this is a set phase based on the coefficient of t squared, and it's going to go through minus 3 because there's a y-intercept, therefore it's going to look like that. And essentially you can see that if I want to find the range of y's, which is looking at the range of y against t, I can safely say that it's going to be starting from that point onwards going down. So now all I need to do to finish off this question is to find this value. Okay, so how can I do that? As you can see, once again, this is the turning point, and we know that at turning point the gradient at that point is flat. So because it's y against t, we call this dy by dt equals to 0, and then in that case here we can just differentiate that and check. So we have, since y equals minus t squared plus 2t minus 3, so we have dy by dt equals to minus 2t plus 2, equate that to 0. I have t equals to 1, so I can use that value of t to find y, which is y equals minus bracket 1 squared plus 2 bracket 1 minus 3, which gives me minus 1 plus 2 minus 3 give me minus 2, and hence that point there is in the coordinates of t comma y, so t comma y 1 comma minus 2. So we know that it starts from minus 2 going downwards. In other words, to finish that off, we have the range of y, or the range of the Cartesian equation, will be anything which is less than minus 2. So I just need to finish that off with a set notation with y such that y is less than or equal to minus 2. Okay, so that is how we can find the answer here. Okay, by the way, so since to be more precise, that's one thing that I've done wrong so far. It's not going to affect the answer for A, but in terms of the way that I draw the graph, there's something wrong, because t cannot be 0. So if I draw the graph here, when t is 0, we got minus 3. That is the y-intercept. So at that point here, actually, I'm going to put it as an empty node. Okay, so I shouldn't have that connected. So it should be so you draw the whole graph, but when it go past the y-axis, it should be an empty node there, and it just carries on. Then how come the answer is still y is less than or equal to minus 2 without any effect? Because at the same level, there is a value of t that will give me the same value of y. Okay, so at the end, that is the answer for question 6. Now let's move on to question 8 in the same exercise. So in the first part, they want us to find the Cartesian equation and state domain based on that. Okay, so let's do this. So find the Cartesian equation, and then normally in exercise 8a, we can just make t the subject for the simpler equation, and I will start with x. So x over 3 is root t, and t is x over 3 all squared. Okay, so we have t equals x squared over 9, and then you can plug it back in into y. So I have y equals t cubed minus 2t, and y equals x squared over 9 all cubed minus 2 times x squared over 9. Okay, and we have therefore x to the power of 6 over 9 cubed, which gives you 7 to 9 minus 2 x squared over 9. So that's the Cartesian equation because we successfully get rid of all the t's as required. And to finish off part A, they want us to state also the domain of f of x. And in this case, well, you can kind of get the it's very hard for you to get the answer by looking at the Cartesian form because we are not really sure how to sketch that. But luckily, once again, we can just look at the parametric form and find it. Okay, so once again, if I want to find the domain of the original function f of x, this one, I can just find a range of x equals 3 root t, okay, which is looking at the vertical form once again, x equals 3 root t, and I want to draw it based on that domain. So we're just gonna start from 0 and draw to 2. And if you know how to draw y equals x squared, I just need to reflect this along the y equals x, the mirror line, and hence I got this soft shape. Okay, and then since I just need the values from 0 to 2, I can get rid of everything else. So since this one there's not much of a difference, you can just highlight at this part. This is our this is the range of possible values of x, and all I need to do to finish this off is to substitute t into it, which will give me 3 root 2, which will give me the domain. So you might ask here a question, so do I just substitute the values, the intervals, the endpoints into both x and y to find the domain and the range? Okay, so the answer is no, and we can show it by looking at part B. Okay, so let's take a look. So we have first of all, part A still haven't finished yet. So about this, so to state the domain finally, so domain of f of x at the end will be just that number, so x such that it is in between 0 and 3 root 2. Okay, right. Now next part, part B. So they want us to show that dy by dt is 0 at that point. So just to show that, that's fine. Y equals t cubed minus 2t. So I can just differentiate this and substitute the value of t they give us. So the gradient at t equals square root of 2 over 3 is going to be 3 times root 2 over 3 all squared minus 2, which is 3 times 2/3 minus 2. That gives me precisely 0. And where do you think I can label this point actually? Okay, so at this is the y equals f of x that they draw for us, and we can see that at this point here we have a turning point which will give us dy by dx equals to 0. And if dy by dx at that point is 0, dy by dt at that point is also 0. So actually here t is square root of 2 over 3, okay, and by substituting this value back into both x and y, I can find my I can find my coordinates. And hence, since I want to find a range of values of f of x, which is again looking at the vertical axis, so all I need to do is to find two things. I need to find value here and the value there. Alright, so that value, once again, we know this is the endpoint. This is when t equals to 2. So I can just substitute it back to find that value. So let me call this point B and point A. So point B, I can find the value of y by substituting t equals to 2 into the parametric equation for y. We have 2 cubed minus 2 times 2, which gives me 4, which makes sense based on our graph as well with those scales. And for point A, again, I can just substitute t as square root of 2 over 3 into the expression and find it. So here I will get a decimal number. So this time I'll just plug it in so that you can see what is going on. So I have square root of 2 over 3 cubed minus 2 times square root of 2 divided by 3. And as you can see, we have a negative number minus 1.009. Okay, but actually, if I want to rewrite my answer, since this is a core maths paper, all I need to do is to leave it as an exact answer, and I can do that by factoring out square root 2 over 3, left me with 2/3 minus 2 inside. Okay, and that also helps you to see why we got a negative number, because we have the number inside the bracket as negative. So I have minus 4 over 3 times 2/3. Okay, so this is the y coordinate at that point. And since this is where we ranged, so the range of f of x for part C will give us just y such that it is in between these two numbers. Okay. All right. So here you might challenge that we said that at the start, if I want to find the range of y equals f of x, I should draw this graph. Okay. That is also true. Okay. So we can actually, in fact, for fun, I'm just gonna find the range of here using just this graph with that range. So I have y equals t cubed minus 2t, which is a cubic function. So I have t bracket t squared minus 2, which if you draw the graph, this is a happy face, happy ending, and it has roots at minus root 2 and positive root 2. So let me draw that first. Okay, and then since based on the domain that they tell us, I just want it from 0 to 2. So actually, the curve that I'm looking for is just this part here. All right, the rest I don't really need it. So I can just highlight this part. So from the minimum point all the way up to where we end, which is 2, comma, a coordinate will be my range of f of x in a y against t graph. Okay, so how can I find this point? Once again, we know that this is dy by dt, which actually we got it. This point here we have root 2 over 3 from part B. And then if I want to find the value of y at that point, it's just like what we did there before. It is 2 cubed minus 2 times 2. That also again gives me 4. And what about this point here? Once again, I just need to substitute the value of t into it. So it's actually the same thing. Okay. So if I want to find the value at that point, so this is when t equals square root of 2 over 3. So I can just substitute into the parametric equation. And once again, you see we get identical numbers. So here it is 4, and this point here, it is again square root of 2/3 times 1 minus 2/3 minus 2